Hello students and welcome back. So now we are going to talk about our next combinational module, and that is a demultiplexer. So in this video we are going to talk about that what exactly is a demultiplexer, how to design a 1x4 demultiplexer and how to write a Verilog code for the same. So let us get started. So demultiplexer is a dual of the multiplexer. In digital logic, dual stands for opposite logic. That means if something is going to work with logic 0, the dual will work with logic 1. So it is going to work in exactly opposite manner of a multiplexer. It is going to have one input and n select lines will be there, and based on the combination of these select lines, this one input will be allocated, will be assigned to only one of the output. What is going to happen to the remaining output pins? Well, they will be assigned 0. So if I have 8 output pins, only one of them will have the value of input. Other 7 will have 0. Now, how to design it? This is the block diagram that we have. We have one input which is data and represented by value x, and there are two select lines S1 and S0. So if there are two select lines, that means I can have 4 output variables. Here y0, y1, y2 and y3 are represented by 0, 1, 2, 3. Now, based on the value of S1 and S0, the value of x will be transferred to one of the output variables. So if it is 0, 0, then we can see that only y0 will receive x and other 3 will have 0. Now x can be 0 or 1. That means y0 can have 0 and it can have 1 value as well. Similarly, for all other combinations, the same logic will work. Like when the combination is 1, 0, then y2 will be x. Now, how do we connect a multiplexer and demultiplexer in real-time systems? So this is how we connect. On the left side, I have multiple users. On the right side, I have again multiple users. U1 want to connect with U33 or sometime U22 or U11, anyone. If you look at the possibilities, any user can connect to any user. So I need n cross m number of connections if n is the number of user on left side and m is the user on the right side. So here we need 16 wires if I want to connect each user from left side to the right side. That will be a very complex circuit. But what we say, they are not connecting all the time. They will rarely connect. So we use multiplexer. Sometime U1 want to connect, so we pick U1 and then we say, okay, where do you want to connect? So then he will say U33, because at one time U1 is going to connect only at one of them, and then from DEMUX we select U33. Next time U3 want to connect with U11, then we will assign the respective values of select line in MUX and DEMUX, and U3 can connect to U11. How do we implement? So let us go to Vivado and write the code for the demultiplexer. So we have a demultiplexer 1x4. There is one input x, two inputs are S1 and S0, and then there are 4 outputs y0, y1, y2, y3. So how do we allocate these? Well, the logic is simple. What is the value of y0? y0 is equal to x when S1 is 0 and S0 is also 0. So we can say Y0 is AND of x, S1 bar and S0 bar. So this is the logic, this is the expression, and similarly we can write for the others as well. So we say assign Y0 equal to x, and then we say complement of S1 and again and we say complement of S0. So that is our assignment, and then we can have it for the other three as well. So here is Y1, Y2, Y3. So everyone will be AND with x. Here it will be 0 0, then 0 1, then 1 0 and 1 1. So these are the 4 assignments, and that is our code. We save it, and now we are going to generate the schematic. So here we have the schematic, and you can see x is going here, and then S1 and S0, and then we have the 4 outputs Y0, Y1, Y2 and Y3. Let us cross check the functionality as well using the simulation. So now let us look at the waveforms. This is S1, this is S0. When we look at this combination as 0 0, so whatever is the value of x, it is going to Y0 and the remaining 3 are 0. When we have 1 0, then it will go to Y2. When we have 0 1, then it is going to Y1, and when it is 1 1 in this case, then it is going to Y3. Other 3 in all the cases are always 0. So this is how a demultiplexer works. So students, now we know about multiplexers and demultiplexers. We are going to take a new module in the next video, and that is decoder. Keep learning. Thank you.